Hello, good morning. My name is Henry Max Okofi. In today's lecture, we're going to talk about row number systems. Our objectives for today are to talk about rational and irrational numbers. We'll talk about how to represent row numbers on number line. We'll talk about how to compare and other row numbers. We'll talk about approximation and rounding up of row numbers. We'll talk about significant figures. We'll talk about recurring decimals. We'll also talk about standard forms. We'll also talk about properties of operations and then binary operations. Okay, let's zoom in quickly. So before we start, we need to revise certain definitions, okay? So we need to be clear on what natural numbers are, what whole numbers are, what integers are, what rational and irrational numbers are. So when we say natural numbers, what are they? So natural numbers are also known as counting numbers, okay? So natural numbers or counting numbers are the sets of numbers that starts from what? 1, okay? So 1 apple, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and above, okay? When we talk of, and then when we talk of whole numbers, so whole numbers, you are talking of counting numbers, okay, plus 0, okay? So whole numbers start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now when we talk of integers, okay, what are integers? So integers, you are looking at both positive and negative whole numbers, okay? Positive and negative whole numbers, 0 inclusive, okay? So from negative 100, you add 0 to positive 100, okay? It's an infinite set, okay? Good. So negative and positive whole numbers. Okay, with 0 inclusive. Okay, so when we talk of rational numbers, what are rational numbers? Okay, so rational numbers basically, okay, they are talking about positive or negative fractions, okay, or integers, or recurring or terminating decimals, okay. So positive or negative fractions, okay, integers, or recurring or terminating decimals, okay. That's what rational numbers are, okay. Good. Let's talk about irrational numbers quickly. So when we say an irrational number, what is it? So irrational numbers, you can't represent them as common fractions, okay. So irrational numbers can't be represented as common fractions, all right. And why can't it be represented as common fractions? Because they have non-terminating or non-recurring so you have non-terminating or non-recurring decimals, okay. Or you can say that they produce infinite decimals. That is, the figures after the points, they keep on going and going and they don't repeat themselves, okay, like rational numbers. All right, now take note, these numbers have specific signs we put by them, okay. So irrational numbers are represented as H, all right. Natural numbers or counting numbers are represented as n, whole numbers as w, integers is designated as z, rational numbers is designated as q. Okay, good. So basically, these are the important definitions, all right? The main focus is these two. So rational numbers, positive or negative fractions, okay? Integers or recurring or terminating decimals, okay? Basically, these ones can be represented as a over b, right? As a fraction, all right? Good. But for the non-terminating, for irrational numbers, they are non-terminating or non-recurring decimals. Okay, they produce infinite decimals. Okay, so for example, something like √2. If you punch this off on your calculator, you keep on getting infinite decimals. Sorry, something like pi. You punch pi on your calculator, you get an infinite decimal, right? You punch the square root of any prime number, okay, 3√5, all of them, you get an infinite decimal, right? So quickly, you're going to draw a diagram on the board, okay? I'll give you a better understanding of what we talked about earlier. So basically, when you're asked about what a raw number is, okay, yeah, it's just a collection of rational and irrational numbers, okay? Good. Let's use a Venn diagram, okay, so you understand it better. So if we were to use a Venn diagram, okay, raw numbers will be the universal set, okay? This will be raw numbers, okay? And then this h here, which is the irrational numbers, would be here, okay? Because it can't be found in rational numbers, right? And then rational numbers will be this big circle, okay? And within rational numbers, we have integers, okay? And within integers, okay, we'll find whole numbers, okay? Why? Because whole numbers start from 0. And then within whole numbers, we have the natural numbers or counting numbers, because counting numbers start from 1, okay? Oh, sorry, rational number, q. So basically, this is how a Venn diagram is going to look like, okay? Raw numbers is the universal set, okay? H, which is irrational numbers, cannot be found, okay? It's not a subset of rational numbers, okay? It's on its own, so it will be found here, right? It's a complement of q, right? So it can be found here, right? Good. Now, what is q? Q is a rational numbers, okay? And rational numbers consist of what? Integers, consist of fractions, consist of whole numbers, right? Good. So which means that integers can be found within rational numbers, right? And the whole numbers start from 0. And we said integers are what? Both negative and positive whole numbers with 0 inclusive, alright? So which means whole numbers can be found within integers, right? Then natural numbers or counting numbers and numbers that start from 1, alright? So if it starts from 1, then it means what? It can be found within whole numbers, right? Because whole numbers start from 0, right? Good. So basically, there's a Venn diagram that will going to represent what we've talked about earlier, okay? So quickly, let's talk about number line. Okay, let's talk about number line. So what is a number line? Okay. So typically, this is how a number line is drawn, okay? Then we put some figures by it, right? So this is our midpoint, that's our 0. And these are important information you should put in your head. On this left side, this is where you can find the negative values. Okay. And on the right side of the 0, that's where you can find positive values, okay? Alright. So for instance, if I asked you to show me where positive 2 is on this number line, positive 2 will be on the right side of the 0, okay? So this is 1. So this will be 2, right? This point. If I ask you to show me where negative 3 will be, negative 1, negative 2, negative 3. This is where negative 3 would be, alright? Good. So you are going to solve some examples on this so that you get a better understanding. Let's go into our textbook for some questions. This so represents range of values. So represents the following on on a number line. Okay, so S is such that X is a raw number. X is a negative 1, A, B. S is such that X is an element of raw number. Take a third example. Okay, so let's draw A. Okay, let's draw A. So it says X is such that X is an element of raw number, okay, and X is what? Greater than negative 1. Now I'm going to show you a trick. So these are 0, okay, negative 1. So negative 1 will be somewhere here, okay. Now in order not to get confused, alright, anytime you see a greater than or the less than sign, okay, and there is no bar beneath it, you don't shade it, alright. So you just draw a big circle on it or a big 0 on it like this, okay. Now, where is the arrow of the sign pointing to? So this way. So it's pointing that way, okay. So just go this way. Alright. B says that what? So you draw. You're given two values, okay. So these are 0. You're given 1 and 2. Alright. Good. Now, so you draw your first circle on 1. There is no bar on it, so you don't shade it. 2. There is a bar under it, so you shade it. Right? You just draw it this way. All what this is asking for is the range of values between 1. The range of values between 1 and 2 inclusive. Okay? Good. C is also asking for what? The range of values between 1 and 3, with both of them inclusive. Alright? So 1 and then 3. There's a bar under 1, so I shade it. There's a bar here as well, so you shade it. Then I draw. Alright? Good. Okay. So now we are going to talk about fractions, okay? We're going to talk about fractions. So when you are asked what fractions are, so fractions simply means a part of a whole, okay? Fractions, they simply mean a part of a whole, okay? Now there are several types of fractions, okay? You have the proper fractions. We have improper fractions. We have mixed fractions. Okay, so basically these are the three main types. Okay, then we can talk about like fractions and then unlike fractions. Okay, let's just add those two as well. So when we say a proper fraction, what is a proper fraction? So proper fraction, all what it means is the numerator, okay? The numerator is lesser than the denominator, okay? So the numerator is the value on top of the bar, okay? Or the division sign, okay? And for proper fractions, it should be what? Lesser than the denominator. So for example, 1/2 is a proper fraction, okay? 1/3 is a proper fraction. 1/4 is a proper fraction, okay? And when we talk of improper fractions, it means that the numerator is greater than the denominator, okay? So 6/5, 3/2, 5/4. These are what? Improper fractions, okay? Now when we say a mixed fraction, so mixed fractions, okay, when you have an improper fraction, you can convert it to a mixed fraction, okay? So for example, this 6/5, if we were to convert it to a mixed fraction, that would be one whole number. So 5/5 plus 2/1, which is, we'll make it 6, okay? So that would be one whole number, 1/5, okay? 3/2 can also be converted to an improper fraction, okay? How will we do that? So that will also be 2 and 2 plus 1. That would be 1/2, okay? 5/4, that would be 4 and 4, okay? Rather than 1. Making it a mixed fraction as well, okay? Good. Now when we talk of like fractions, all we mean is you are comparing two fractions, okay? Or you are dealing with two fractions with the same denominators, okay?